It's getting nervous, but
That's definitely a first for any OMNeT event that I have attended.
it has to be special, you know, like flash impact, I don't know.
So, welcome back to the next session. This session is a bit of a mixture between research contribution and some invited presentations. So, we're going to start with a research contribution. Afterwards, we have two more invited presentations, and so I'll give the microphone the ground to our first speaker, Trang, and she will tell us all about Wi-Fi-Direct simulation in OMNeT and INET.
Thank you for the introduction. In this talk, I will present our contribution on the implementation of the Wi-Fi-Direct in OMNeT++. So here is the plan of our presentation. First, I will introduce a little bit about the Wi-Fi-Direct networks. Then I will present how the IO2.11 networks are implemented in OMNeT++, about our implementation, about the test, and at the end I will show you a demonstration. So, Wi-Fi-Direct is a new operation mode in the Wi-Fi networks. It's new in comparison with the two classical modes, the infrastructure mode and the ad hoc mode, which have been divided in the standard of the IoT.11. But in practice, we have Wi-Fi-Direct already in the smartphone and tablets that we have today. We can see the Wi-Fi-Direct mode as a combination of the infrastructure mode and the ad hoc mode. That means in a Wi-Fi-Direct group, one station will be selected or elected to be the access point and serve the connectivity to the other members in the group. Wi-Fi-Direct is widely used with the smartphone to share files or to exchange pictures, for example. And in our research, we studied the use of Wi-Fi-Direct for device-to-device communication in order for the offloading. For example, in the cellular network, we can use Wi-Fi-Direct to offload the cellular base station, or in a dense wireless network in an auditorium, for example, for a lecture or a conference, we can divide the whole network into clusters, and each cluster will be a Wi-Fi-Direct group, and to offload the infrastructure, the Wi-Fi infrastructure, and also to reduce the interference level. So there are 4 steps divided grouped into 2 phases in a standard group formation. First of all, the device will scan to detect an exiting group or an exiting group owner. If there is no exiting group, so the device will move on the file phase, or file here means finding a peer. And in this phase, the device will switch between the search and the mission state in order to detect a peer which also wants to establish a group. And this phase will finish when 2 devices sending the probe request and the probe response over the same channel, so 2 devices can detect each other, and then they move on the geo negotiation in order to elect or to select one of them to be the group owner. After that, to finish, we have the provisioning phase. Essentially, the two devices exchange authentication frame and so on to secure the communications. In order to select the group owner, we use the three-way handshake, and especially each device will choose a value called the geo-intent value, and the device with the highest value will become the group owner. Here is the implementation of the AO2.11 network in OMNeT++. So we have mainly three modules. The radio modules for the physical layer, the MAC module for the MAC layer, and the management module in which we can configure a node to be a station or an access point in the infrastructure mode or an ad hoc node in the ad hoc mode. In our work, we have modified the management module in order to implement the behavior of the Wi-Fi-Direct node, and also to allow a node to declare or to be configured as a Wi-Fi-Direct station. So we have implemented the necessary message exchange for a standard group formation, and also for a node to choose an existing group. We follow the technical specification of Wi-Fi-Direct defined by the Wi-Fi Alliance. To test our implementation, we create a topology with 3 hosts and define 2 scenarios. The first scenario is for the standard group formation, so we test the 4 steps: scanning, finding it here, selecting a group owner, and provisioning. And after that, we test for the connectivity. And in the second scenario, we test the autonomous group formation. Autonomous group formation means we can configure or we can choose in advance the host will be the group owner. So at the beginning, this node will announce itself to be the group owner and create a new group. So there is no geo negotiation here. Okay, so here you can see, here is the discovery phase. You can see that the 2 devices discover each other when they send the probe request, and the other node can send the probe response over the same channel. And the average discovery time is between 2 or 3 seconds, which is the case in practice. Here in this picture, we can verify the negotiation, the geo-negotiation phase. Here we can see that there are 2 messages: the negotiation request, response and confirmation, and finally we can see here host 1 becomes the group owner because it starts to send beacon messages. So the third host here in this case is host 2 will join the group, and then we can test the connectivity. So here you can verify that if in this case we can see that host 1 is the group owner, that means it will play the role of an access point. So when host 0 sends a ping to host 2, this ping message will be relayed by host 1, which is the for the ping reply. The ping reply will be relayed by host 1, which is the group owner. But in the second example, the second ping here, when host 1 wants to ping host 0, and because host 1 is a group owner, so you can see that the ping message and the ping reply are sent directly. For the autonomous group formation, we use the E file, the initialization file to configure host 0 to be the group owner and the other hosts are clients. So that means the host 0 will announce itself at the beginning of the simulation that it is the group owner and start to send beacon. And other hosts just scan for the beacon and join the group. And we can verify that. Here, for example, you can see that in this case, host 0 is the group owner. So when host 2 ping host 1, you can see that the ping message will be relayed by host 0, the group owner, and the same for the ping reply. Okay, so before going to the demonstration, I will give a short conclusion on this contribution. So Wi-Fi-Direct is a new communication mode for the Wi-Fi networks, and it's widely used by smartphones or tablets that we have today. So in this work, we have implemented the Wi-Fi-Direct protocol in OMNeT++, following the specification defined by Wi-Fi Alliance. And this implementation can be used for research, for protocol design, for performance evaluations, especially on device-to-device based communication in dense wireless network. So now I will show you. So in the paper, you will see a link to our code, and you can download the code to try. In the README file, there is detailed instruction to install or to integrate our implementation in the INET framework. And there is also this example, so you can try. So, okay, so, sorry. So it's not. Okay, good. Okay, so in this example, you can see that finally, host 1 becomes group owner because we keep the color is blue, and the other hosts become red. Okay, so let's have a look. So you can see that the stations start by scanning to detect whether there is an existing group owner. In this case, no. So they have to try to discover a peer. You can see that the discovery phase will finish when there are two hosts sending a group request and answering by a group response over the same channel. So the discovery times can vary because it's quite random. After the discovery phase, we move on the negotiation phase. And here you can see the three messages for the negotiation request, response, and confirmation. if you look in detail of the negotiation request, you can see that the values are of the geo intent here of host 0 is 5. And so let's see the response. The geo intent of host 1 is 40. That's why host 1 become group owner. Okay, so after that we have the provisioning phase. After that, host 2 will join the group. And then we have the ping. And you can verify easily here. For example, this one. This ping is from host 1 to host 0. So you can see that the ping will be sent directly. And for example, let's see another example where there is some relay. 2 to 3. This one is to host 1. Host 1. I would like to see something to host 3, between 3 and 3 and 1, 3 and 1, 3 and 1. If we can find something between 3 and 1, we can find there is a relay. Here we have 2 and 3. Yeah. Okay. I'm sorry here. Yeah, I will not take time just to find the right ping, but there should be relay here. Okay, this one and this 2. Yeah, because this one is the group owner, so I would like to show some. I'm sorry here I don't see between 1 and I would like to do something between 1 and 3. Dot 1 and dot 3. Maybe I stopped too early. So let's 1 minute to try the autonomous, because the autonomous formation is easy. So when we so in the autonomous formation, we have configured in the INET file that host 0 will be group owner. So you can see that there is no negotiation, geo negotiation. But at the beginning, host 1 will become the geo and send beacon messages. And then, okay. So you can see that there is no geo negotiation, just for the group joining. And yeah, again we can verify for the ping. Yeah, for example, this one, because host 0 is the group owner, so you can verify that this one when oh sorry, let's see this one. Host 0 again, host 0. Yeah, take this one. The ping 0 is from host 1 to host 0. Okay. This one is direct. Okay. Sorry. Yeah. Yeah. This one should be a relay. This one should be a relay. Here we have host 2 is pinging host 1. Yeah, and we see that host 0 relay the message. And the same for the ping relay. So, oh, thank you. So.
Okay, this is the speaker here. We still have time for a couple of quick questions. Maybe I can start with the first one. Your current code stand is based on INET 2.6, I guess, 2.5?
The INET 2.6, yeah, I don't remember exactly the version because it's my my student who implement. But yes, I think the exact version can be found in the paper. But let's say we take the last version of the INET, where the implementation of IO2.11 are quite stable. That means we don't change. So I think that it does for, yeah, maybe 2.6, 2.2 or 2.4, something like that. But yeah.
So we're going to have a talk tomorrow about the use developments of the HR2.11 model in INET 3. And maybe it might be interesting for the future work to think about an integration in INET 3 in this case. And more like an idea, less like a question.
Yeah, I think that we don't need really require a really new version of OMNeT Plus, because just take I think that 2.4, I don't remember, but quite old version where the implementation of AO2.11 already quite stable for a long time.
Yeah. Other questions directly for Wi-Fi?
So you guys have implemented the WiFi-Direct. So usually the WiFi-Direct, because we are also interested in using it. So I'm happy that you guys have done it, and we hopefully can use it. So in WiFi-Direct, like it switches modes between WiFi-Direct and standard Wi-Fi access point. Is that feature there, or is it doing only Wi-Fi-Direct?
It's optional. That means in the future we can implement that. And in our research we have already implemented that for the research in the dense Wi-Fi network. And yes, we use let's say time-based sharing in TA. That means we switch between with only one interface. We switch between the Wi-Fi direct and the
standard
infrastructure.
So that the implementation that you guys have released doesn't have this both. Or I didn't understand. Sorry.
In the real network.
No, the code that you have released. You said you released some code.
In this one, no. But
okay.
in our, because we are publishing in another conference, but rather than just after.
Okay, good.
That,
Yeah.
Okay. For the study of dense wireless network, and especially it's for the auditorium and UPMC. We intend to give tablet to students for the lecture, and so we also study to use the Wi-Fi direct to try to upload or optimize the performance of the network in a big auditorium. offload the cellular or the network infrastructure. For example, the clustering problem, how to cluster, how to divide a big network, for example, a stadium or an auditorium into group, how to select the group owner. We can use the SDN, for example, some kind of SDN to configure, to organize the network, the big network. And then because we can divide the big network into the small group, so we can use the power control to reduce the transmission power of inside the group, so to reduce the overall interference level and can